Hello there, geometry class. Welcome to the last lesson of chapter 9. Your test will be coming in the mail short. No, I'm just joking. There's no test. So last section of section 9, law of sines and law of cosines. We get to have some fancy stuff with this, but the law of sines, law of cosines are kind of neat because they can be used with any triangle. Okay. Previously, sine and cosine, it had to be a right triangle to use it, but there are some formulas that we have here that will apply to any triangle that they give us. And not just finding the lengths and the sides, but also finding the area of a triangle when it's not a right triangle. Okay. The first thing I want to cover, this is page 272. So we're doing the law of sines, law of cosines. A triangle in standard form has A, B, and C. Capital letters are the angles. So the angles are capitalized. The side lengths are lowercase. Okay, so triangle ABC, notice A, B, and C are the vertices, they are the angles, and they are used capital letters. The lowercase ones represent a length. So lowercase is a length, uppercase, capitalized, is an angle measurement. Okay, so that's I wrote angle there already. Okay, now the other thing is notice that angle B is opposite side B. So corresponding angles and sides are opposite each other. A, B's, and C's will be mostly used. The corresponding angles and sides are opposite each other. So opposite angle A is side A. That's opposite. That's across. It's not the adjacent ones. Opposite side C would be angle C. So if I did a triangle with X, Y, and Z, if this is an uppercase X, this side would be the lowercase x. This side would be the lowercase y, and this side would be the lowercase z. Okay, so sides are lowercase, angles are uppercase, capitalized, and they're opposite each other. Okay, page 273, what are the law of sines and the law of cosines? Need this for your first questions. So it's just formulas that can be used to find the angles and sides for any triangle. Okay, for any triangle. Formulas that can be used to find the angles and sides for any triangle. Okay, I'm going to keep going. Pause it if you need to. Okay, this is your area formula. Okay, the area of any triangle given by 1/2 the product of the lengths of the two sides is calculated this way. 1/2 BC. Now notice these are lowercase, so those are sides. That's side B and side C, and then you have to have the sign of the angle. Okay, so 1/2 BC times the sign of the angle. So these two are sides. They're lowercase. That's a capital letter. That is an angle measurement. So 1/2 BC times the sign of A, or 1/2 AC times the sign of B, or 1/2 AB times the sign of C. So notice what happens in each of these formulas. You have to have two sides, and we call that the included angle. Included angle. Two sides and the included angle. So if I know A, B, and C, I'm going to take A times B times 1/2 times the sign of C. Two sides and the included angle, you can figure out the area of that triangle. What you're doing is that finds the height. Part of this formula is finding the height. So here, if you take B as your base, A times the sign of C gives you the height of that triangle. That's opposite over hypotenuse. So you find the height, 1/2 of the height times the base. So those who got that, that's good. If not, just know where to get the formula. You need two sides and the included angle to use that formula. So here are your law of sines and law of cosines. Okay, law of sines is a little bit easier to set up. Law of cosines can be a little bit trickier. Okay, they can be written in either form. Sine A over side A. So sine of A over A, sine of B over B, sine of C over C. Or A over sine A, B over sine B, C over sine C. Okay? So these are proportional. You won't put all three parts in your formula. You'll just have two of them. Okay? So the sine of an angle over the length opposite that angle. Okay, so it's the sine of an angle over the length opposite that angle. Two of them that have to be equal to each other. So in order to use this, you must have one set of angle opposite sides that are known. You must have one set of angle / opposite sides that are known. Congruency theorems that fit this are angle, angle, side, angle. Sometimes this profanity one does work with this, side, side, angle, but it doesn't work too well. Okay, so if you have any of those sort of situations, this is going to work. We're going to look at some examples. You can tell how you can use it here. Okay, but you have to have one set of angle and opposite sides to be known. So if you have C, side length C, and angle C, you can use this formula. If you have side length A and angle A, you can use this law of sines. If you have B and angle B, you can use the law of sines. Now you may not always have that. You won't always have that on your example, on your practice ones. So one there that doesn't fit is like if you have a triangle and this is 10, this is 120, and this is 13. So I have side, angle, side. So notice 13 is opposite this angle, which I don't know. 10 is opposite this angle down here, which I don't know. So here's ABC. 120, this would be opposite B, and I don't know that. So I don't have a set of angle opposite sides. So I can't use the law of sines, which means I have to use the law of cosines. Okay, so here's the law of cosines. Looks very similar to the Pythagorean theorem. Now notice there's one more step that would have to be done, and that is you have to square root all that. So A is actually the square root of B squared plus C squared minus 2BC cosine A. Woo! Look at that length of one. It's easier than what it looks. Okay, B would be the square root of A squared plus C squared. Notice I'm looking for B, so I have to use the other two sides, A and C. Minus 2 times the other two sides. Now that times the cosine of B. Okay. And C is the square root. There's C, so I have to use A squared plus B squared. Minus 2 times A times B times the cosine of C. So the only time the C shows up is in the angle, not the side length. So if you had side, angle, side, you can use this. Because if I'm looking for side length B, I could use this one. That makes this the A. This is the C, so I know A and C, side, angle, side. And you can also use a side, side, side. That gets into inverse stuff. I don't think, yes, we will have it. Ooh, okay. Alright, so there is they didn't give us that. I'll do some of those examples. Okay, notes in the student journal, I'll have to add to that. Okay. For the side, 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 if you know three sides, then you have to look for an angle. And that's going to be a little bit new. We have to use what they call the inverse cosine, which is going to be a secondary function. Notice there's cosine. I'm going to have to use inverse cosine. Let me get my scientific one here. So I'm going to have to use inverse cosine. Okay, so if you have three side lengths, 10, 12, and 14. Okay, so if I had three side lengths, you will have to use this function right here, cosine to the -1. That refers to the inverse, and it finds an angle. Everything we've done so far has been finding sides. This will find an angle. And you'll need these formulas here. So if you're looking for angle A, you will have to use this function right here, and then everything that's in front of it will have to be used like this. This is going to be b squared plus c squared minus a squared, that's on top, divided by 2bc, that's on bottom. Okay, so we'll have to use that inverse cosine function, and then these three values here. Notice the a is going to be opposite the angle that you're looking for. Okay, and I can write this for each of these. If I want angle b, I'm going to take inverse cosine. Now it's going to be a squared plus c squared minus the b squared, that's all on top, over 2ac. That's it on the bottom. So notice ACs and ACs minus the b squared. If I'm looking for c, that's going to be the inverse cosine of, so now I'm looking for c, so it's a squared plus b squared minus c squared. That's all on top, minus 2ab, that's what's on bottom. Okay, so pause it, get those written down. We'll come back, we'll practice those. So page 276, all that they give us for extra practice is here. First of all, use a calculator to find the trigonometric ratio, round your answer to 2 decimal places. If they want the sine of 225 degrees, all you need to do is sine 225. Make sure you have a decimal point. That's negative 0.7071, 4 decimal places. So yes, use a calculator. Cosine of 111, cosine 111, boom. That's negative 0.3584. Make sure you round correctly. Tangent 96. Negative 9.5144. Okay, so you're just using calculator for that. Okay, next exercise 4 and 5, find the area of the triangle, round your answer to the nearest tenth. This is where we get to use these formulas here. Okay, so this is D. What I'm going to do is I'm going to say, okay, this is going to be A, this is going to be B. So I know angle C. I'm going to rewrite these. We know angle C. That's going to fall into this category right here. I know angle C. A and B are going to be the two on the other side. So this is going to be the A, this is going to be the B. So the area is 1/2 times A times B times the sine of 79. So 1/2 times A times B times the sine of 79. You type that in correctly, to the nearest tenth, 61.8 square units. 61.8. Okay. Just looking on your assignment, side angle side. So if you take, you're going to notice the habit here is, even if they don't give you the A, B's, and C's, you have side angle side. It's just going to be 1/2 times the two sides times the angle. 1922 angle. $85. So area equals 85.0. Put the 0.0 so we know we rounded to the 10th. Okay, here we go. They're using those law of sine formulas. Solve the triangle. This will be it. We'll do, I think I got 5 or 6 of these, so it may take a little bit of time. Round the answers to the nearest tenth. So solving the triangles, this right here means find all missing angles and side lengths. That's what it means. Find all the missing angles and side lengths. So on 6, I notice that I have angle C as the only angle I don't have. I have the 50 and the 80. So the measure of angle C would be 180 minus 50 minus 30. Subtract those two from 180. That's 180 minus 180. That's 100 degrees. So this is 100 degrees right there. Now to find, this would be side length C. This would be side length A. I have my corresponding part here. You see how I have a side and an angle opposite of it. That means we are using the law of sines. So the law of sines is what's going to be used on this one because I have that relationship right here. So the law of sines states B, you can use either one, B over the sine of B is going to equal A over the sine of A. So you just set those corresponding parts equal to each other. So I have, okay, I know 22 over the sine of 30 has to equal, let's do A first, A over the sine of 50. Now remember, sine of 30 and sine of 50 are specific numbers. Sorry, there you go. It's not 30 and a 50. It's a sine of 30 and a sine of 50. So if you solve this, you can cross multiply and divide, but let's just cross multiply up here. Leave this on this side because we want to get the A by itself. So A equals 22 times the sine of 50. Divide that by the sine of 30. 22 sine of 50. And I'm going to divide that by the sine of 30. And I get 33.7. Okay, so there's A. 33.7. So now we're going to come back. We're going to do the same thing for C. 22 over 30 has to equal C over the sine of 100. So same thing, C is going to equal 22 times the sine of 100 and divide that by the sine of 30. 22 sine 100 divided by the sine of 30, you get 1/2. Nah, I didn't hit the divided by. That doesn't sound right. 22 times the sine of 100 divided by the sine of 30. Not the answer. Boom. 43.3. That sounds better. So C is 43.3, A is 33.7, and then angle C is 100. We found all the remaining sides. Okay, and they're going to have blanks for each of those. And you just have to fill those in. You are rounding to the 10th for each of them. Rounding to the 10th. Okay, so on 7, notice we have a set opposite each other. But now we have a 16, we are missing this angle. So we're going to have to find an angle first. Now whenever you're finding angles, you're using those inverse functions. And this is a sine inverse, not a cosine this time. So since I'm looking for an angle, I am going to put the angles on top. There we go. Since we're looking for an angle, I'm going to put the angles on top. So on top is whatever you're looking for. What are you looking for? So we're looking for an angle, the angles will go on top. Looking for a side, the sides will go on top. So these are the sides, these are the angles, because they're capitalized lowercase. So I'm going to have the sine of 82 over 25 equals the sine of B over 16. So I'm going to multiply the 16 over. I get the sine of B equals 16 times the sine of 82 divided by 25. So when you're looking for an angle, you use the inverse operation. So now I use the inverse sine of 16 sine 82 divided by 25. Make sure all of that's in your parentheses. So inverse sine of 16 sine 82. Now I can close that one, but do not close that one yet. Divided by 25. Now close it. You get 39.3. About 39.3 degrees. Okay. So now you have two angles. You can take 180 minus 82 minus 39.3, and you get 58.7 for this one. And now you can use the normal law of sines to find side length C. So again, I would go back to my given. I have 25 over the sine of 82, I'm looking for a side length, is going to be C over the sine of 58.7. So C is 25 times the sine of 58.7 divided by the sine of 82. 58.7. There you go. 25 sine of 58.7 divided by the sine of 82. And you get 21.6. Okay. Just keep trying these. Okay, a lot of algebra in this part. Okay, round the decimal answers to the nearest 10. Okay. 8. Notice we have side, side, side. We do not have any angles. So the only formula we have for that is this formula right here, side, 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 based off the law of cosines. Okay? This formula for the law of cosines, you are required to know an angle. If you're looking for a side, you have to know an angle. The law of sines, you have to know angles to do that. So if you have side, 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 you have to use the alternate. It's called the alternate form for the law of cosines. Something you can Google too to get more examples with that. So let's find, I'm going to find the biggest one first. So the biggest angle has to be opposite the biggest side. So I'm going to find angle B. So if I want angle B, I have to do the inverse cosine of a squared plus c squared minus b squared over 2ac. So I'm going to label those. So this is my B. My A has to be opposite angle A. My C has to be opposite angle C. So C is 3, A is 5, B is 7. So this is going to be the inverse cosine of 5 squared plus 3 squared minus 7 squared, all divided by 2 times 5 times 3. So inverse cosine. Now I want you to make sure this top and bottom are separated. So I'm going to put extra parentheses around them. So inverse cosine and extra parenthesis, 5 squared plus 3 squared minus 7 squared. Oops. Close that parenthesis. Divided by 2 times 5 times 3. Oh, another parenthesis, hang on. Divided by parenthesis 2 times 5 times 3. Close parenthesis, close the big parenthesis. Okay. And you get 120. So B is 120 degrees. So now you have an option. You can use the same formula to find A or C, and then take 180 minus those two to get your third one. Or you can go back to the law of sines and use it to find A or C. So let's practice this again. Let's say I want to find angle, let's do A, angle A. So if I'm looking for A, I have to do the inverse cosine. So if I'm looking for A, I'm going to start with the other two, BC, minus A squared over 2BC. So B and C should be on either side of A. So you're taking if I'm looking for this angle, I'm going to start with the two sides that make the angle. So parenthesis, 7 squared plus 3 squared minus 5 squared, all over 2 times 7 times 3. Okay, so I'm just going to go, okay, so inverse cosine, extra parenthesis, 7 squared plus 3 squared minus 5 squared, did it again, 5 squared, close parenthesis, divided by, start a parenthesis, 2 times 7 times 3. Close parenthesis, close parenthesis. And you get 38.2. So now I'm just going to take 180 minus 38.2 minus 120, and you get 21.8. All right. So side, 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 that's what you got to do, that example right there. Let's practice this one. This is not a 6. That's what had me confused there for a little bit. This is a B. So this is angle, side, angle. So if you have an angle, side, angle, remember you have the two angles. You can find it to find this third side. Then you have a set. So if I take 180 minus 18 minus 60, I get 102. So then you'd set it up 32 over the sine of 102 equals eeny, meeny, miny, mo. Let's find A. A over the sine of 18. So 32 sine 18 divided by the sine of 102. And you get 10.10. 10.1. Okay, so 32 over the sine of 102 equals b over the sine of 60. Again, make sure you are writing this down. You're not just watching me do it, but you're trying to get ahead of me, or just stopping it, working it, and then coming back and seeing what the answer is. So 32 times the sine of 60 divided by the sine of 102. B is about 28.3. Okay, so that's one situation. The other one, this is a side angle side. We haven't used this formula yet. So this is another law of cosines, because you don't have a set of opposite set things going on here. So if we're looking for B, this is where we have to use this one right here. B is the square root of a squared plus c squared. And remember, A and C are flanking the angle you have. They're on either side. They're the adjacent ones. So there's A and C, and then that's the cosine of B. So this is A, this is C, and that's the angle B. So B would be the square root of 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of 125. Make sure you look and see where all those numbers came from. And that can also all go in the calculator at once. The square root of 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of 125. And you get 26.6. Okay? Alright, try your best with this one. This one is a little bit trickier here. Let me know what questions you have, how I can help you with this. Don't stress yourself out too much about this. Those in advanced math will see this again at some point. But I think it's kind of neat. It applies to a lot of bigger triangles, triangles that aren't right triangles, any shape you can use these on. So good luck. Stay Bluebird strong. Stay positive. Keep telling yourself you can. Be your biggest cheerleader and go for it. Do your best.